My final project examines St. Peter's Basilica, constructed between 1506 and 1626 in Vatican City. St. Peter's Basilica embodies the religious, political, and artistic culture of 16th century Rome. During this period, the Catholic Church sought to reaffirm its global authority through monumental architecture. Renaissance culture emphasized humanism, symmetry, classical geometry, and artistic craftsmanship. These values are visible in the basilica's massive dome and classical altars. Structurally, the building must resist enormous compressive force from its stone walls and piers, as well as significant lateral thrust from the dome, with wind loads, dead loads, and the weight of masonry all influence the form of the building. The original construction process used materials and methods typically of the Rome Renaissance. Builders relied on stone, brick, mortar, timber, scaffolding, and marble. The labor forces were organized through guilds and made up of specialized craftspeople, masons, stone cutters, carpenters, and sculptors. Tools included treadwheel cranes, wooden hoists, chisels, hammers, ropes, and pulleys. Falsework played a central role, especially in constructing the dome. Carpenters erected massive timber scaffolding, centering, and internal support frames that held the dome's masonry in place until it became self-supporting through compression. Transportation depends on pre-industrial systems. Stone was moved by ox-drawn carts, barges, horses, and labor. Illumination and ventilation were provided entirely by natural sunlight, openings, and oil lamps, creating a difficult working environment. If St. Peter's Basilica were built in 2025, modern culture wouldn't have shaped the form differently, but would have greatly altered the construction process thoroughly. Contemporary Rome values sustainability, safety, and technological precision. These cultural priorities would influence the basilica's construction by emphasizing accessibility, energy efficiency, ambient friendliness, and seismic resilience. The building process today would use reinforced concrete, structural steel, precast components, and CNC cut stones. Tower cranes and BMI modeling would guide construction. Instead of timber scaffolds, the project would use modular steel scaffolding, hydraulic shoring, and steel dome formwork. Materials would arrive on flatbed trucks and be lifted with cranes, dramatically increasing speed and safety. The interior workspace would be lit with LED work lights and ventilated with mechanical systems. Past failures strongly influenced St. Peter's design. Collapses of earlier Gothic vaults demonstrated the danger of thin masonry, while the risks of Florence Cathedral taught builders the importance of reinforcement, thick piers, and careful sequencing.